Hello, this is Satish and welcome to my YouTube channel. So, what is a gate driver and how does it work? In simple terms, a gate driver can be defined as an electronic component that provides the necessary voltage and current to turn on and turn off a power device. It is generally used in the field of power electronics and serves as an integral part in the heart of power converter applications. Power MOSFETs and IGBTs are voltage controlled devices and require specific values of gate to source and gate to emitter voltage differentials to work as a switch. It is usually in the range of plus 15 volts to turn on and 0 or minus 5 volts to turn off. To drive what is usually called a low side power device, the setup is easy to implement since the source or the emitter terminal is referenced to the power supply ground. To drive a high side switch correctly, we need to contend with the fact that the source terminal would be floating between the ground and the power supply based on whether the top switch is on or off. This is where a gate driver becomes handy due to its ability to level shift the driving voltages with the power converter switching states. Okay, enough with the theory. Let's build a gate driver test setup to implement this in the real world. I'm using a half-bridge gate driver for this video to show how to control both the high side and a low side power MOSFET. I've chosen part number IR2104. The pin connections are shown here. Pause the video if you need to fully understand how the components are connected. Pin 1 is VCC and it's connected to a 15 volt source. Pin 2 is the PWM output from a microcontroller or a function generator, and this is the PWM input for the gate driver to work with. The voltage levels for the signals are plus 5 volts and 0 volts. Pin 3 is the logic input for shutdown. I've connected this pin to a voltage divider with 1K resistors to the main plus 15 volt power supply. Pin 4 is common and is connected to the ground of the plus 15 volt power supply. Pin 5 is the gate driver output PWM for the low side power MOSFET. A series 5 ohm resistor controls the peak of the gate current to the MOSFET. Pin 6 is connected to the midpoint of the half bridge configuration or the source of the top MOSFET. Pin 7 is connected to the gate of the high side MOSFET. A bootstrap capacitor of 10 microfarad is connected between pins 6 and 8. Also, a blocking diode 1N4007 is connected between the plus 15 volt power supply and pin 8 as shown. The scope is connected so as to get the gate to source voltage of the top and the bottom devices. I've used a math function in the scope to get the gate to source voltage of the high side MOSFET since the measurements are referenced to the ground of the power supply. We can see that the gate driver beautifully provides the required voltages for the power MOSFETs to turn on and turn off. An important feature built in the gate driver is the dead time between the switching signals. From the datasheet, it can be seen that we can expect a dead time of 520 nanoseconds. When we measure this, we get a dead time in the same ballpark as shown, about 450 nanoseconds. Hopefully, this video provided some background on gate drivers and showed how one can be used in a real application. Thanks for watching and see you in the next video.